According to Stephen Hawking, artificial intelligence might just make the human race obsolete. The late scientist claims were based on the inability of humans to compete with the fast-paced learning process of AI. So, what exactly is artificial intelligence? And why did it prompt one of the greatest minds of the 21st century to warn us against it? Let us start by describing the technical aspect of this often misunderstood process. Artificial intelligence is the simulation of human intelligence in machines, from deduction to pattern and image recognition. AI facilitates the rationalization of actions for machines in order to learn and problem solve. To put it simply, artificial intelligence is when machines are programmed to think like humans and mimic their actions, simulating their intelligence without using pre-programmed pathways. This includes the replication of human-like traits such as learning and problem solving. Artificial intelligence has the ability to rationalize, take actions, and learn through iterations. So, how successful is AI at simulating human intelligence? And is there any difference between artificial and human intelligence? Although artificial intelligence is faster, more accurate, and unable to get stressed or tired, scientists have not been able to perfectly emulate human intelligence. To successfully imitate human intelligence, one requires creativity, common sense, and emotions, which computers haven't been very good at replicating. While some emotions have yet to be simulated, AI is already a complex field with many subparts that are hard to dissociate. Robotics, multi-agent systems, expert systems, the list goes on. But most of them depend on the core idea of machine learning in some way, which we decided to focus on today and describe in more depth. Some people might have a hard time differentiating artificial intelligence, machine learning, and deep learning. It turns out these are just different layers of the same cake. AI is the overarching technology, which involves systems with the ability to learn and reason rationally. As we have seen, machine learning is one of the many subsets of AI. Lastly, deep learning is one of the many types of machine learning, which uses artificial neural networks to sort through data and produce an output. Now let's get technical. First, machine learning. This subfield is dedicated to algorithms and statistical models that computers use to perform a specific task without using explicit instructions, but relying on patterns and inference instead. Now is a good time to debunk the many fantasies around the term algorithm. This word has been thrown around by many startups and entrepreneurs to give a futuristic edge to their products. But it turns out an algorithm simply describes a set of rules that define a sequence of operations. See, no reason to be afraid. Now, back to machine learning. There are two core systems in machine learning: supervised and unsupervised learning. Supervised learning is based on knowledge about a certain input and output, where an algorithm is trained to predict the correct outcome by supervising the program through trial and error. And supervised learning goes a step further, as we have no knowledge about the output. Unsupervised learning is an attempt to find patterns and clusters within a data pool. Ultimately, at the core of every machine learning system is the search for a relationship between an input and an output in order to achieve accurate predictability. Here's an example. In order to predict the outcome of an election, we can use supervised machine learning. We only need an Excel sheet with enough data about our voters, such as their age, study level, or income. The more information we have, the better. We can now set aside part of the data and use the rest to train our algorithm. It is crucial to test the algorithm on data that was not used for training in order to assess the quality of its prediction. Let's move on to deep learning. This is the cutting edge of artificial intelligence. Instead of teaching computers to learn from data, which is how machine learning works, with deep learning, the computer trains itself to process information. It is known to be one of the most accurate fields of AI at the moment, replacing rule-based algorithms in most translating softwares, for example. Deep learning started becoming an AI star for its ability to recognize patterns in images, among others. The key characteristic of deep learning to achieve such astonishing results is the fact that it uses artificial neural networks. In the simplest form, ANN, as we call them, have only three layers: an input layer, a hidden layer, and an output layer. In reality, Neural networks can have a variety of interconnected layers, allowing for a greater accuracy. Therefore, deep learning systems are self-teaching, learning as they go by filtering information through multiple hidden layers, just like humans do. Let's make this clear with an example. What I will be demonstrating is known as CNN, or convolutional neural networks, a type of neural architecture often used for image recognition. A picture, possibly featuring a cat, is fed to the algorithm. This picture is then split in a grid in many smaller pieces, kind of like pixels. Each of these smaller pieces will be assigned a neuron, which might activate itself or not, depending on what it sees. This will go on through some layers of neurons, what we described as the hidden layers, until we reach the output layer. Depending on how neurons activate, one of the output possibility will end up being chosen. In this example, if it is a cat or not. But enough technicalities, let us move on to the business side of things. First, the degree of maturity in the AI industry and its products experience. Some key characteristics that define the AI market as fast-growing and highly innovative with increasing competition are compounded annual growth rates of 20% between 2015 and 2020, estimated revenues are $40 to $55 billion in 2020, and that AI technology is part of Industry 4.0, which revolutioned our lives. Here are some emerging technologies expected to exponentially increase and thrive, according to Gartner for 2019. Naturally, AI is featured. What we're witnessing is a feedback loop between tech companies and consulting groups. They create hype and in turn have high expectations for innovation in the upcoming years. Similarly, AI products are in a growth stage with improvements, innovations, and expansion of their distribution. Here we can see the hype cycle for artificial intelligence, as defined by Gartner in 2019. We can clearly observe that AI is still in its infancy, even though some of its innovations are quickly becoming obsolete. Speech recognition, for example, is barely considered AI anymore, as it has reached its peak. But if older AI products are not considered AI anymore, can artificial intelligence as a whole reach its maturity? Only time will tell. Now, how does the AI industry affect its stakeholders? Just by looking at the stakeholders, we can clearly observe the huge impact that AI has on our lives. AI is here to stay, but it comes with some concerns. Among many others, consumers should be concerned about privacy, ethics, rules of regulations, and ease of use. The list goes on. Circling back to our Stephen Hawking quote from the beginning, it is in the stakeholders' hands and best interest to set out rules and regulations to ensure that AI's possible excesses are mitigated and controlled. Finally, let's have a look at the AI vendors, which make this innovation and revolution possible. As organizations rely more and more on AI systems, the sector is becoming highly attractive for the various vendors. According to Crunchbase, there are now over 9,000 vendors in the AI marketplace. Now, there are several layers through which AI is distributed, and some are more concentrated than others. For example, we have industry-specific or vertical applications, like e-commerce with AI-driven operations management. There also have been horizontal applications of AI, with Alexa or Google Home. AI-enabling technologies, which help develop new processes for efficient operations, and AI infrastructure like cloud computing. Out of all the companies shown, we can single out some, like Microsoft with their Azure Cloud, Anaconda, which is an integrative programming and learning platform for AI, and IBM's Watson, which is an AI aimed at diagnosing diseases, especially useful in today's context. To sum it up, success in creating AI would be the biggest event in human history. Unfortunately, it might also be the last, unless we learn how to avoid the risks. Understanding how AI works is the first step toward mitigating the risks. With this presentation, we hope to have clarified the vast field of AI and maybe reduce the risk of being taken over by sentient machines in the near future. Thank you for your attention.